In this video, we're going to look at how to express solutions. That is, how much stuff is dissolved in our solutions. And to begin with, we're going to just look at some terms, and these terms are dilute and concentrated. And they are really qualitative, and that means there's no real number to say, something is dilute below this number or something is concentrated above this number. But really, it's more of a sense chemists have to say if you have a lot of stuff in your solution, you are concentrated. If you don't have a lot of stuff in your solution, you have a dilute solution. And when we talk about concentration, it's the amount of solute in a given solution, right? And so we have different ways to look at this. And I put this giant star here because that's probably what you encounter the most, especially in lab. And that's molarity. And that's the amount of solute in moles divided by liters. That's big M. Now you can also have little m, molality, which is the amount in moles divided by the mass in solvent. So the only difference between molarity and molality is your denominator. Molarity is denominator liters. Molality is your denominator in weight. Now you can have mole fraction, which is the amount of moles of your solute divided by your total amount of moles of solute in solvent. Your mole percentage, which is mole fraction times 100. And parts per million, which is the mass of your solute divided by the mass of your solvent multiplied by some factor, 100 times 10 to the 6th or times 10 to the 9th. If you want to talk about percentage, parts per million or parts per billion. Then you have parts per volume, where instead of just mass, you do volume, but it's the same thing, same idea. All right. So how do you make a solution? Well, first you want to know what concentration of solution you want. So that's usually in molarity, molality, percentage. And from there you can back calculate to know how much solute you need. And the way you make it is you have this instrument, which is called a volumetric flask, and you add your solid, then you add water, but not to the line. So this line says, you're at 1 liter. You want to add water a little underneath the line, because when you mix, the solution might expand a little bit. So once you mix, then you can add water to the 1 liter line, and that's how you make a solution. So let's look at molarity now. Molarity, moles divided by liters. And so let's say that you have a sugar solution that has 2 moles per liter. So in 1 liter, you have 2 moles of sugar. 2 liters, 4 moles of sugar. 0.5 liters, 1 mole of sugar. So molarity, moles divided by liters. Molality, moles divided by weight. Again, very simple calculation. Your moles of stuff divided by your weight of solvent. And parts solute and parts solution. So parts per million, billion, percentage. You can either do this by mass or volume. And you just have to keep the same type of measurement. So if you're doing weight of solute, has to be weight of solution. If you're doing volume of solute, has to be volume of solution. Right? So here we have parts per million. Sorry for the poor PowerPoint here, but to do parts per million, you just measure out your mass of solute divided by your mass of solution. For water, we have 1 liter of water is 1 kilograms of water, and then you multiply it by 10 to the 6th. For parts per billion, very similar calculation, except you do it by 10 times 10 to the 9th. And if you ever looked at the water report for San Antonio, or if you followed the Flint story when it happened, you'll notice that, we have parts per billion there. For example, in Flint, Flint had over 5 parts per billion of lead Or that's what they were looking at, and the highest value was 25 parts per billion. Several examples were 100, and several examples were 1,000. That is way over the EPA limit. So when we were looking at lead in the Flint water supply, you're measuring it in parts per billion there. The next way we can talk about this is solution concentrations or mole fractions. And it's just how many moles of solute do you have divided by how many total moles that you have. And really, you can when you do this in fraction, all your moles fraction should equal to 1. And this is a unitless measurement. Because you have moles divided by moles, your answer will be unitless. And if you multiply this by 100%, you'll get what's called the mole percentage. That is, for example, if you have salt water, what percentage of that solution is made out of salt in terms of moles? That's what a mole percentage is. And that's it for this video. I'll see you in the next video.